something. So in the last exercises we have been working on our singly linked list, and today we would want to implement a few useful functions like find, erase, insert before, insert after, and realize the way we have implemented our iterator, since it's only a singly linked list, is not actually sufficient to be really flexible. So if you want to insert something in the middle, having only a pointer to the current element would be sufficient in case of a doubly linked list, because we know both elements on both ends which are pointing to this element, so we can make any change we want. But with a singly linked list, we unfortunately do not have this ability. We only have information pointing one way, so we could not implement an erase, and we could only implement an insert after. So that would be a bit limiting. So I will quickly improve our iterator, and then we will task one of you with one of the first functions, for example, with the find function. So what we need in order to be able to erase elements or to insert before an element is the ability to have all relevant pointers available to us, and this can be done quite easily. So when we take a look on how our list works, we have a head pointer, and then once we are no longer in the head, we have the next pointer. And our current implementation was just pointing to an element, but we can quickly change this to be a pointer to a pointer. And then when we when we take begin, then we will have just a pointer that points on where is it, head. And if we then are inside our iteration, then we just have a pointer that points on the next, which is then stored in the previous element. So this will give us the ability to modify all the information that are required, because we have the pointer to the next element, and we have the pointer that points on us currently, so we can do whatever we want with that. So let's continue. So here this doesn't change, this here changes. No, this doesn't. This one will change, so we need to dereference next. P next, here the same thing. Wait, not quite. This will be like this. So we need to. Okay, so we dereference our pointer to a pointer, then make the arrow operator on the pointer, get the next element, take its address, and save this to our next value. Same thing here. Zack. This doesn't change. This doesn't change. This changes slightly. This changes slightly. And here the initialization will be, of course, we take the address of head. That might be it. Let's quickly run if we have not to see if we have not forgot anything. Let's put a breakpoint here and there. So we have our list. It has 3 numbers. And then if we run it, okay, it seems we have forgot something. So it didn't work out quite right. Let's iterate through it. So we have our begin. We will take our iterator. Now we have head, that should be correct. One step. So pointer points to this thing, which then has an exponent and data. That looks correct. Let's get out of there. Okay, then end is just a dummy. It should work. Okay, this should also be fine. This is just a comparison. Okay, and here we want to get some data. So next is a pointer, we dereference it, and then it's a pointer on a pointer, so this should be correct. Okay, so it printed correctly, and then we have a let me get out of there. So 2, 1, and now 0. So it also printed, it probably is. Let's see, so here, that's the problem. Next becomes a null pointer, because there is, wait, is this correct? So this thing becomes a pointer that points to a null pointer, okay. Then we have here our comparison. We have next, which is a null pointer. Yeah, okay, that's the problem. So what happens is our comparisons do not longer work, since our next pointer will not be null. So the simplest approach is just to compare the values of those pointers, but this brings another issue, that then here we would have a null pointer, so that would that would then crash. How do we fix that best? We could introduce either a dummy variable, or we could get a get function that gets yeah, let's do it like this. So row, we always need some sort of dummy, because we want when we create the end iterator, where is it? Here we want this to work correctly. So let's just, for simplicity, introduce here a static. That's not the most elegant solution, but it's good enough. Static. And if we have, we give the pointer to the dummy. Okay, now it works correctly and prints. Okay, so the first assignment will be to implement the find function. Where is it? Here. So it should take an value and then give us the iterator. So first of all, let's increase this to, let's say, 10. And let's then here make this also print in one line. Oops. Space and null. So they both print the same thing, and now here in the middle we get our find. So int iterator f for find is equals my list point find. Did we use small or capital letters? Let's keep it small. Find. Let's say we want to find the value number 3, and then if find is not equals end, then found f found f. Okay, so that's how this is supposed to work. So would anyone like to volunteer to implement the find uh, function?
I can start.
Okay.
Let's see. Yeah. Oops. Okay. Mechanism.
Mm-hmm.
Then we have the things this.
Mm-hmm.
Mm, 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 mm. Okay. Mm,
Mm-hmm.
is mm, 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 mm. Then we just return the iterator. Oh yeah, and if there is nothing found, we return end again.
Okay, so conceptually that is correct, but there are a few practical problems. So our iterator does not take an entry type as initialization parameter. So we need to create a new constructor that would take a pointer to a s entry, a pointer to a pointer to an s entry, and then the loop needs to be updated to actually work not with a pointer to a p entry, but a pointer to a pointer to a p entry, such that it can be then passed to the new iterator construct.
Okay. Um,
I would suggest starting with adding a new constructor to the iterator in line 120.
um, so it's again as entry and then pointer to a pointer, right? So,
Well, you need the s iterator first, so it needs to
oh,
have the same name as the
oops.
type itself. You don't need to pass list anymore. The S
Mhm.
entry replaces this. Well, you need a bracket, of course.
Um, the-
The function will need a body.
yeah. So what exactly is this constructor? So
It's a function which is called when an object is created. So when
mm,
you create a new instance of sIterator, you call
yeah.
one of the constructors to populate the initial state of the object. So its task here will be to assign the argument, which you have not given a name yet, so the argument needs a name, like just pnext or whatever, to our mpnext.
Okay. So mm, okay, I'm sorry, I'm stuck a little.
So in line
So
121, you need to add a name for the argument. For example, the letter P, like pointer, without a comma,
mm,
before the comma. Yeah. And then you just need to assign. So you can see in line 124, we have defined a variable on our object mpnext. And to this, inside the body of your function, you want to assign P to mpnext.
okay. So, oh,
Not quite. So uh, mpnext is a variable of our iterator object. It's not a variable of the pointer to a pointer P.
mm, mm,
You just write mpnext is equals P semicolon and close curly brackets. Yeah. And now what we need is to change the way the loop operates such that pEntry will no longer be just a pointer to a entry but a pointer to a pointer.
okay. So entry. So then we have to change here something, right?
Well, first the type sentry asterisk to sentry asterisk asterisk. Then the
Mm,
assignment, you need to take the address of arrow p head instead of its value. You can take a variable's address by using the AND operator.
mm,
Not here.
yeah. Uh,
Before the M.
yeah. So
Okay. Then the test condition. We no longer test if the pointer to the pointer is not null, but if the pointer pointed to by our variable is not null. So we need to take the value of the pointer. If you have a pointer, you can get its value by using the asterisk operator. Not here. Before the
oh,
name. Asterisk pEntry. Okay.
mm,
And here we want to again take the address of pnext. No, that null was
also,
correct. Now we only need to update the next statement by taking the address of our p-entry arrow next. Okay, and now p-entry arrow will of course not work. You need to take the value of p-entry and then apply the arrow operator on it. You can see an example of how to do it in line 110.
Yeah, okay. So shall I remove this whole?
No, just edit the line and correct the use of entry. Oh, and entry is missing an epsilon.
Yeah. Just so it's so you mean like this? So like in line
No,
100?
well, you are still missing the
Oh,
comparison. You want to compare with what? As you had before?
okay. This page, it's just right here.
The semicolon is of course misplaced. It should not be there. And arrow, and asterisk p-entry needs to be in brackets. Because otherwise the asterisk would try to apply to data and that would not be valid. And the white space is obsolete, yeah. Okay, that might work. Let's try it out. I already made a test case.
Yeah.
Just run it. Wait, what? No, it didn't run. May I have the mouse for a second?
Yeah.
Why? Fine. This is S iterator. Oops. That was my mistake. S iterator. Okay, let's run it again. And I didn't fix the last one. Plus we still have an error somewhere. S iterator. Yeah, and this is not quite right. We need to take here the value of our. Okay, and apparently we have another. Now it doesn't know which one of those is meant. This is annoying. Let's do it like this. We remove this. We will only have one constructor, and here since we have something, we can add it, and the dummy will be something that we only need for our end. Actually, that makes it even a bit more elegant. So the issue that we ran with this error message was that if you just pass null ptr, then it doesn't have a type. And if you have two constructors which take a pointer, it doesn't know which one of them to take since they have the same name. And found 3 worked, so great. But maybe one more small additional assignment. Let's also implement the next find version, which takes a start value, a start iterator. It is a very small change. You only need to basically change here the initial condition. So you can copy the whole content of your previous function and just edit the initialization of p-entry in the loop, and then that should already implement our find with start iterator. Although, wait a second, one more issue. Of course, iterator should be of the right type. I will quickly fix this everywhere. Otherwise, we will run in this error multiple times. Okay, you can take control of the mouse and copy the function and make the adaptation.
mm, and this is going to mm, and so then oh, that,
Well, you don't want to take a value from
oh,
our member, you want to take a value from start. If you delete the greater than sign and type it again, the IntelliSense should show you which members do you have available. Yeah.
so
Well, almost. You don't need to take its address. This is already a pointer on a pointer. Okay, that is it. And now we need a test case. So let's what do we want to do? You can add another find term inside the f not equals mylist_end and look for, let's say, the number 5 and see if it can be found as well. Of course, it really becomes interesting if we would have multiple entries with our um, number 3, and then we could use this find with start to iterate through all the 3s that are inside our. Well, you first need to find it, so you need to define a new iterator like f2 for example, and then use mylist_find, passing to it the new number to be searched for plus the existing f iterator.
so can I just copy this and adjust it?
Yeah.
Yeah. And this should be yeah, and two. And what did you mention? I should find 5.
For example, yes, something that's after 3. If you search for 2, it will
Yeah.
not, it is supposed
Yeah.
not to work. But you need to add, of course, the start argument. And here, where the cursor is, you need, of course, to write F2. You want to
Yeah.
print the other one.
Okay. If and um,
In line 181, you need to add the second argument to your find call.
this is
It's the previous iterator, just F.
yeah.
Okay, let's run. Wait, it didn't run, it didn't
Yeah.
compile. Double click on the arrow to see what happened. The iterator is const. May I have the mouse? Wait,
Yeah.
how do we fix this? Just cast this to a non-const. Or we could also make this const. doesn't matter. Will work both. No, wait. Wait, so start is our iterate and it has type is right. We have already defined a arrow operator. That needs to be a dot, not an arrow. That was the. Although it might still complain about the constness, but it works. But it didn't found it. Okay. Because we are going from the back to front, or rather our numbers are reverse order since we are only appending. No, sorry, only prepending them. In this case, let's search for number 1. And now it found it. Okay. So that's that. That works fine. There is a bit little utility in such a find function since if we are looking for something, then we already know what it is. So what one might want to do to improve such a find mechanism is to make it a little bit more complex. So first we will do a few minor improvements. So we will just here tune f what comma begin, not begin. We just take here this thingy so that we don't have too much code duplicated, and then we will make a copy and make an next version of that. Find x, and this thing we will implement in a more flexible way. So we've already seen how one uses callback functions with parameters, and we'll just apply this to our find. Find x func and param, and find x. We'll also here get oh wait, I started editing the wrong one. I meant to edit this one. Find x func and param. Okay, and now I'll change this as a boolean return value. So the idea is that instead of doing the comparison manually, we are invoking the find function, where the compare function with our data and the parameter, the optional parameter, and this thing will tell us if we have found what we're looking for or not. And if it says yes, then return it. If it says no, then we continue. And the idea is that if you add, for example, an element to a list which has, let's say, an ID number and then some other property and some other property and some other property, if you would use the default comparator, well, technically you can define a custom comparator which would only, for example, compare only ID or only some other field, but that would be very restrictive and would in principle break the semantics of a comparison operator. A comparison operator should always compare all relevant fields and not be artificially restricted. So in this case, you can just, when using find x, pass a find function which will, for example, just look for one of multiple fields and then return you the iterator, and then you actually gain knowledge, because then you get an object which has the ID we're looking for, but it has all the other properties which you did not necessarily knew when specifying what you are looking for. Or you could make a find function which accepts a whole range of values, which we'll do right now. So we go to main. We will make now a loop. So for auto f3 is equals my list. So this is not the most elegant way of doing it. Yeah, let's do it manually. So f3 is equals my list begin. Just don't make anything, or maybe make a while loop. While oops, f3 is not equals my list end. Okay, so now we are looking for something. So maybe let's f 3 is equals my list find x. Zack. What was our arguments here? We have them. Boolean condition comma null ptr. We don't need an argument. And now if this thing is not end, then we do something with it. For example, print that still needs some improvement. Found x, and now to our condition. Okay, here it shouldn't be t, it should be int, since our type is int. One thing that is commonly used when defining container types is to add a public typedef t type, so that we can reference the type of our particular implementation in a reliable way. So here we could instead of just writing int, write list type, and it is kind of more elegant. But let's go to our compare function. So if if asterisk value, no, if value is already value. If value is, let's say, greater 7 and no, less than 7 and greater 3, then return true. Else we return false. And let's see, this will not be quite right, because once we have found something, we'll re-find it each time. So if this is not end, then here we need to advance this to f3 to the next possible value. Let's see if we can make this somehow more elegant. So let's make this a for loop. Put this here, put a plus there. And here let's make this, but so if this is null, then break. Yeah, okay. That might be right. Let's see. So we initialize it to begin. We check that it isn't end. We do our find x and get something, or get a end. If we got an end, then we just break. If we didn't got an end, we got what we're looking for, so we print it. Then we go to plus, so that we move to the next element, which then will be the first to be checked. We check if that might already be the end. If it's not, then we repeat. Yeah, that should be fine. So we have found, we have end line, and then yeah, that's alright. Let's run. And it's broken. It always searches the same spot. This is not great. We need to debug that. I mean, it starts from 9, so it should start with 6 down to 4, and then it should bug out. So our plus somehow don't operate as expected. So let's see. here we have our f, which points on something, which points on something, which contains the value number 6. Yeah, then we... Oh, stupid mistake. We of course need to tell it where to start looking. It was a Foundex 654 that works as expected. So yeah, so this is now quite a powerful little find mechanism. It's really flexible, and even though we only have a single linked list, this already gives us quite nice functionality. So the next thing we will want to implement will be, according to our master plan, the erase function. So any volunteers for implementing that?
Yes.
Okay, then take control.
Can I get the ID to connect?
Yes, I will write it in the chat window. 1 second. So oops, the IP was this, and the port was, I do not remember, 6, I guess maybe this one. I will check that while you are trying out how that works, which port I have given to this thing. Switch IP.
I think it asked for password.
Yes, password is. I think it was this one, or maybe with a capital letter at the beginning.
Okay.
You should have a few tries. It should not fail.
CPP. Yes, I have it. Okay. So first it gives an iterator and a starting point, and I think first we need to remove the head, I think, to the next point. So what is the head called here?
So the m variable has a p head member,
Yes,
and inside your entry, it's called pnext.
px. So I think px.
No, pnext.
Pnext.
But
Pnext.
that's on your on the thing that the iterator is pointing to. It does not exist globally.
Okay. So I think I will use it is iterator dot pnext equal no, I think no. Equal yes.
You don't specify the. So you don't need an in C++. You don't use a dot after the type when you define a variable. So you just iterator space p if you want to make a iterator called p.
Okay, so I say pnext.
before that, you wrote iterator.p. That is not correct. If you want to make an iterator, you just write s iterator space and then the variable name. You don't use type dot to initialize anything.
Okay. So I'll write is iterator
Mm-hmm.
and say p.
For example, yeah.
Yeah.
Although I would call it I, but that's up to you.
Yeah, sure. Equal is iterator. No.
You don't need to write. So what do you want to do? You want to create the
Uh,
iterator that would point to the next element, right?
yes.
So you need to access start dot
Start
dot,
dot
and then you have
yeah,
here the MP next.
empty
Although
next.
you need to initialize the iterator, so you need to call its constructor. So you would
Uh,
not use the assignment. You would use open bracket.
okay. Open bracket
And
and
just and then inside you can pass it the
value.
well you I think you will need a additional line because
Okay, I can call it like this, equal null.
no mm,
Is it true? Like if I make it into two
this is
lines?
this is not so this is not C++ syntax. So if you initialize something, you specify the initialization arguments inside the round brackets.
Yeah, it curly brackets. Yeah.
No, in curly brackets you have a function body
Okay, so I have to do it here.
inside. Yes, start
Yes.
next, but you need
Okay.
to take like the thing that next points to.
Um, it's I think this.
No, you have start next and start. So first of all, start next is a pointer to a pointer. So you need to take the value of your p next.
Ah, okay. Star.
Mm-hmm. And then you put the whole thing in yet again a set of brackets. And then you can use the arrow operator on your next to get um, its own internal next.
So I say here is iterator.
Not quite. In the line you created before. Now you just created a copy of the current iterator. Not even. This will not compile as is. What you
Okay.
need is you want to take after you have taken the value p next points to, you got the address of an S entry, and from this address you want to take the value of the S entry that is p next, so that you get the next element. And once you have
Um,
this, you want to again take the address of the new p next.
okay. So according to what I understand, so I need to do arrow pointer. Uh,
The arrow pointer you need to do inside the outer curly
bracket
brackets in line 157.
170s. Okay.
No. First, delete both these often arrow operators.
Okay.
Go to line 175.
And 75.
Inside the outer round brackets,
Yep.
on the other side of your statement,
Ah, he. Okay.
and
Now
here you
I
can
understand.
use the arrow. Wait,
And
try again. It should suggest you. Uh,
maybe the stars outside.
no, the star. No, the outside you need something else. Just ignore the intelligence not working. You need the star inside. before after star, yes. And then here you can write MP next. No, M
Okay.
underscore P next.
M underscore B next.
Capital N.
Capital.
And you are missing an E.
Yes.
Okay, and then of this thing you want to take the address. So at the beginning of your statement, inside the outer brackets, you want to make an @ sign. No. Here.
Here.
Okay. I was just trying whether that compiles.
Okay.
But you need to implement a test case, otherwise, since it's a template, the compiler will not will disregard the function. This is the annoying thing with templates, that if you just write them but not use them, the compiler will ignore them unless they are very, very wrong.
Okay. So, um,
So inside the main CPP,
in CPP.
we have, for example, in line 178, where we have already found the letter 3,
Okay.
or even you can just use either F or F2 to erase the value from our list.
Oh, so maybe here.
No, before the loop that does something, yeah. Either 178 or 185.
185. Okay.
There is an empty line below. You can write there your test
Yeah.
case.
Okay. I would say F2 dot delete.
That's not how you use an iterator. You call erase on my list and
Or
pass it the
erase.
iterator to be erased.
F2 call. No, I erase F2
But
and
erased exists on the my list object. It does not exist
yes, another function. So
in
I
the
said
global namespace.
F2
Not F2, my list.
my list.
Mm-hmm.
Uh,
Dot erase, and then you pass the F2 as argument.
and
You need to add a semicolon. Yeah. Okay. Now you can try to run it to see, just to see if. Wait, it's not. It's complaining. Click. Okay. May I have the mouse for a second?
yeah.
P next. We called it P next. MP next. That should be correct. And we dereference this thingy, because P next is a pointer to a pointer. And once we have dereferenced this, that might be only as much as. Why does it say that this is not a member of C list entry? Because we already have here, that would be a dot operator. Nope. Because that's annoying. Okay, I think this will not be needed. So start P next. We take the address of this thing, we dereference it, and this is a pointer. And this of this thing we take the address. Wait. This must be correct. This must be correct. Then we take the value of the point and then of this value on this thing. We should be able to get the other. What was it? Ah, this was only called next, not p next. That's just next. Okay. Yeah. Okay. This is fixed, and of course we want to return I. Okay. So this will do nothing, but it at least doesn't fail.
Okay.
So what we need here is to now, of course, remove the element from the list. So you have created the iterator, which we will be able to return once we have finished the removal process, but you still need to implement the removal process itself.
So first I will say is iterator no start dot next equal delete not delete.
This is not how you do things in C++. Which language are you using usually?
It's sometimes I mix with Python and C++.
So the proper order of operation should be first you should create a pointer of type sEntry. So sEntry asterisk pEntry.
Okay.
Not
S
type iterator, type sEntry.
enter.
Well, the too many typos. sEntry like in line 165.
With E.
But only with one asterisk since it is supposed to be a simple pointer.
Okay. S entry and
Well, one asterisk because we need a pointer. Not at the beginning. If you want to make a type into a pointer to the type, you suffix it with the asterisk.
yes.
Then give it a name.
Um, temp.
Okay. And then you can assign the value of start.pnext pointer. The thing it
And
points to.
start dot m next.
Okay, well that's a pointer to a pointer. You want to take the value of the first pointer, so we need to take the asterisk operator before start. Okay. And the plan would be now you change the linkage so that the element is unlinked from the list. And after you unlinked it, then you can delete your temp using the
So
delete command.
now it's pointer next, and now have start be next, and now I say temp. No, I will delete temp later, so it should be here. Temp,
How you delete things you can see in line 194.
90 fatly delete temp. But yeah, mp head
You should not modify head directly because the value you are deleting might be somewhere inside the list. You need to use your start MP next and modify that.
So I would say start at next equal in next. Now this is pointer to a pointer, so I should put asterisk here.
P next is not a variable on your object. You need to
Reference it with this.
no on this you only have M, on M you only have head. What you need is you need to take the object start next points to, and then assign start next to the thing that start next points to its own next points to. So you need to skip a entry in your chain of. So the way this list works, you have a node, and the node points to the next node, and the next node, and the next node. So it's like a chain,
Yeah.
and you need to skip one of the rings in the chain. So whatever you
Next.
have now, which
Yeah.
points on next, should not point on next, but should point on the thing that the next of the next it points to then points to. So it should point to the over next next. That's a reasonably elegant way of saying it. Not plus one. This is not a array. You need to on your next use the arrow. So first you need to take the address of your next. It's pretty much the same thing we have used inside initialization of the iterator in line 175. Just that you don't take the last reference. Yeah, that's starting to be correct. But the start M next needs to be in brackets and have an asterisk before it, because wait, does it? Wait, let me think. Yeah, it does. Start. That might be correct. So this is a pointer to a pointer. We take the value of it, and then of this thing we take the next thing. Yeah. It's missing a lot of fail safes, but it might work. Try running it. Uh, 177. Wait, something's not quite right. So start. You need to assign to the memory that start MP next points to. So you need to write asterisk start MP next is equals. Not that this was. Yeah. So you need to put a star before the first start MP next. That might be correct. Okay, and it removed the number it removed one. We didn't want to remove one, I think. Wait, may I have the mouse for a second? Oops. Did we look for one? Oh, we looked for one apparently, so it actually removed the right one. So this worked. Let's now take a look to our list. Let's see if we have somewhere. Okay, this brackets probably we don't need. Yeah, this needs to be like this. Good. So what this is missing is any sort of failsafe. So if start would be end, that would so if start would be end, that would crash. If the next element would be already the end of the whole thing, this would also crash. So this needs some safeguards. Do you have an idea what to add to make it safe? Yeah, that's not quite right. So in C++ you write null with a capital with all capitals, or null ptr, and we always here return iterators. So you cannot always return null. You need to return. You can only return null if you have a pointer. If you have an object by value, then you need to return actually an object. Okay, maybe since we are running out of time, maybe I will just quickly improve on this. Okay, so let's see, what do we need to get? So first case, if start should also not be called start, it should be called just e or something. E or it. Right, so if it is equals end, then return it. Okay, so we know that this is not end, so this thing has a value, so the next exists. So we can do this, and we can do this, and we can do this, and then we can do this, and then yeah, I think this is already all that we needed to check for. Okay. So we have 15 minutes left. Does anyone think they could implement one of the insert functions in the remaining time?
I want to try.
Okay.
Yeah.
Then please try.
Sir, we should have a account in real VNC.
Hmm?
We should have account in real VNC. I am
No,
trying.
you don't need any account. When you start it, you can connect without an account.
Okay. I am trying to search, but I am failed.
Did you start at the VNC viewer?
Yeah, I have started.
It
I
should
am
have
writing.
an option when it starts first, like continue without account or continue without login.
So they have a rated sign in the right side.
You don't need to sign in with the service, you only need to provide the IP address and then the password for the machine you want to connect to.
Yeah. Sir, I am not able to. I am trying, but I am not connected with it.
Are you getting this window already or not?
Yeah, I have.
Then add the IP
Sir,
address and port on the
I am
top.
writing C++ 2025 on the top.
No, you need to write 213 dot and so on here. The IP address and the port number.
Sorry,
You need to write the IP address and the port number.
IP address. Sir, you have write it in the message C++ 2025. It's IP address.
There are two messages in the chat. The first one is the IP address, the second one is the password.
Sir, I joined late. Please write again.
Okay.
Yeah.
Someone already did.
Okay. 213. Yeah, it's working.
Mm-hmm.
Sir, it's not taking my password. CPP 2025. It's a password.
Try with capital C.
Okay, okay.
Yeah.
Yeah. Yeah. First, I have to make insert before.
You can just uncomment one of them.
Okay.
Insert before is probably quicker. Yeah, definitely. Just uncomment the insert before in line 184 and implement its body.
Okay. Sir, if I'm wrong, then tell me.
Well, first you need to uncomment the line 185 so that we have our function definition.
Sorry, I can't understand.
You need to uncomment the line 185. Remove the two backslashes because otherwise the line is disabled and there's no function. 185.
185 disabled from this
Remove the two backslashes.
and this one. Okay.
Yeah, now it's enabled.
Okay. Thank you.
And well, you would not work with head. The idea here is that you really only work with the iterator, so with the where thingy. You don't need to access anything on the global object the way it is currently made.
It's not. It's not okay, sir.
So your where iterator, the one that is passed to the insert after as an argument, contains a pointer, all the pointers you need. Basically, one pointer to a pointer which is the current element that you have that it points to. You only need to update the pointers this where points to, or rather, you don't even need to modify the where itself because it's insert after. So you just need to take the element it points to and update this element's pnext variable with the right value. And of course you need to create a new instance of our s entry. So I would start with creating a new s entry object. S entry asterisk new. The s entry asterisk temp is equals new s entry from value, so that it is initialized with our value, and then we continue with that. You don't need that if in line 188. That is not required.
Okay. Remove this.
Yeah, just the whole line. Okay, so you have now your new element, and what you need to do is so you have this where pointer which has the mp next variable, which is a pointer to a pointer. Insert after. So what you need to do is you need to take the things. So you need to take the thing that the iterator points to, and this thing points to the next element. You need to take the value of this next element, assign it to the news next, and then
Yeah.
override the pointer of what where a pnext points to. It's override its next pointer to be the value of pnew.
Yeah, I'm trying.
No, pnew should not point
Like
to
this.
itself. So pnew next should point to where dot
Pinu next
is equals.
dot
No, pnew next is equals.
p new from the starting from
Just
this.
change what's after the equal sign.
Okay. P
Uh,
new.
and then you delete the second the pnew that you have here. No, after the equal sign.
Okay. From this.
Yeah, just delete until the equal sign. Okay. Now write where dot
Where
dot
dot
pnext
p next.
sorry, mpnext, like the IntelliSense is suggesting. Just click on enter. Okay, now you need to put the thing into brackets and put a asterisk before it. No, so there were mpnext.
Empty next, sir.
Where dot mpnext that you've just written.
Yeah.
Put an asterisk before it.
Yeah. Word dot empty next on.
You need to put an asterisk before where.
Sir, I'm not understanding.
Okay, so I have the mouse. So this thingy where mpnext. This is a pointer to a pointer, and we want to take the value where it points to. So you take an asterisk before it, and then what you will get is the value the pointer points to. Then if you take the brackets, it just allows you to use now the arrow operator, and on this you can use pnext. And then you will have, I think, assigned the right value to our pnext. What you now need to change is you need to change asterisk where and pnext is equals pnew.
Here we have to change.
Because you are inserting something into the chain. So you have this chain of elements pointing one to the next, to the next, to the next, to the next. So what you need to do is you need to break the link, insert a new link, and then make the previous element point on the new element, and the new element point on what the previous element was pointing at. Wait, may I have the mouse? So what we have is basically a lot of elements pointing to each other.
Yeah.
And then we create a new element. And what you need to do is you need to break this and make this point on the new element and the new element point on the previous element. That's what we're trying to achieve. And this you can do here by appropriately adapting the pointer values.
We have to make another string like if
So
for this.
you have copied this thing into this, and now this thing's value must become this.
Mm. Yes, and
Without the p next.
no, you have sir. No, no,
Oh no, just the asterisk square and p next is equals.
Equals to p. This will goes to p next again. Yeah. Oh, sorry, p new.
Without the arrow operator and without the brackets. Just asterisk square and p next is equals p new.
Like this.
Nope. Instead of the arrow operator, you need to use the assignment operator. The assignment operator, just the equals sign.
Is this okay? And this.
Nope, it's not okay. Instead of the arrow exclamation mark, you need to just write the is equals sign. And remove the arrow. And also now remove the brackets. And put a semicolon at the end. I see we are running out of time, so I would suggest you try fixing this at home.
Yeah.
And during the next lecture after the holidays, you can finish the implementation.
Okay.
I think this makes sense. And I will take the mouse. And with regard to any homework over the holidays for the rest of you, well, we have the erase function. Let's see, the previous homework was to make this, so homework from the 18, 11, 12. All and yeah, so just implement reverse find. So since the list you should have at home and it should be a doubly linked list, it can be traversed the other way. So just implement a reverse find with start, reverse find x, and reverse find x with start. And then since we already implemented the erase function, I just update it so that it works with the doubly linked list. So it will need to update the pointers not just one way but bidirectionally. Yeah, and that's that. So we will see each other for the lecture if you participate in the lecture, and if you don't, then we'll see each other next year after the holidays. So in this case,
Okay.
happy holidays. And for those
Sir, I want to show how much I have completed.
mhm.
I want to see how much I have completed.
it will not run. It will not work as is.
Okay.
So you need. I don't. Did we write prepare write lowercase even? No. So prepare write is uppercase. And we are not returning an iterator. I mean, we could return. I mean, we can maybe quickly hack something together. We just return. Where? We just return the same iterator since we return inserting after. This is fair. Let's just try it. So we have found. Let's here just insert insert after value 11 after f. But I'm not sure if it will work or if it will crash. We will see, I guess. Oh, it actually worked. Well, kind of. We were looking for 3. Found 3. But we have something is wrong because it's not. So it kind of removed our 3 from the. It replaced it. It's not quite what it should do. So it means. Yeah, it is replacing. So it's not quite right. Why is it not right? So we have 3. Let's see. Prepare write is actually we should have a prepare write also for this thing here, which will be even more problematic because prepare write will invalidate the iterator. So this will need to be improved anyways. So we have our where, our next, and this points to new, and this should be insert after. Wait, might be an easy fix. Might be as little as this. Let's try it again. And it works. Okay, so no extra homework for you. It works
Yeah.
with this small fix. Good. So we are 6 minutes over time, and we are done. So I'll stop the recording.